Now that we know how to convert from logarithmic to exponential functions, now we want to be able to evaluate. So we did this kind of on one example in the last video, but that's really going to be our focus in this video, is to actually find the answer for x. So in this case, if you'll notice, I just said, hey, let's find the answer for x, and then I gave you a page where there were no x's. But really what I'm looking for is, if these said equal to x, what would x be? So I'm really looking for you to solve it. And so I want you to think of it as equal to x, because you can swirl this just like we did before. I can swirl this and say 12 to the x equals 144. And we'll talk about different strategies for when, we have to actually do some work. For this one, I'm hopeful that we can find exact values without having to break a sweat, because I'm saying 12 to what power is 144. So obviously if I took 12 squared, I would get 144, so x must be 2. Same thing on this one. Again, you can think of it as equal to x. So 125 to the x power equals 5. So what does that mean? Well, I know that 125, I want to take it to the x, so I actually want to take a root of 125, because 5 times 5 times 5 is 125. So what I want to do is take a cubed root of 125, and so x would have to be 1/3, because 1/3 is the same as saying take the cubed root of 125 to get 5. Log 1, again, this is a common log because there's no number. So this is 10 to what power is equal to 1? Well, hopefully we remember that anything to the 0 power is 1, therefore x must be 0. Let's continue. Again, making it equal to x, this is 1/2 to what power is equal to 8? Well, I know if I want 2 to be 8, I would take it to the 3rd power. So instead, I'm going to take x to be not the 3rd, but the -3rd, because remember, a negative exponent tells me that I'm going to flip, sorry, I wrote 2 instead of 1/2. So 1/2 to the 3rd would be 1/8, but 1/2 to the -3rd would be 1/8 flipped over, which is just 8. So that's where that -3 comes from. For x, 4 to the x equals 1/2. And if you're wondering just now, man, she said this was going to be easy, but it's not. I tried to get a lot of the fraction examples in here, because obviously those are the hardest. This one is like super easy, and hopefully we can all do this in our sleep. But when you get to questions where we're dealing with all these fractions, and am I using a negative or a fractional exponent, that's why I wanted to make sure I included those here for us to work on together. So 4 to the x equals 1/2. Again, what I want is I want to take the square root of 4 to get 2. And so how do I take the square root? Well, I would have to take x to the 1/2, because that's square root written as a exponent. But that's only going to give me 2, and I want 1/2. And so in order to flip it, that makes my exponent negative. So x would be -1/2, because I want it to be 1/2. And last one. Remember, the base here is e, so e to the x equals e. So e to what power would be e? Well, obviously x would have to be 1. E to the first would just be e. And that is all. So let's take a look at some examples where the method that we just used wouldn't work. Because if I tried to use the swirly method here, it would be 10 to the x equals 23. And that's not something I can compute in my head, because 10 to what is 23? I have no idea. So now I have to use my calculator and come up with a decimal approximation. And lucky for me, I have a log button on my calculator, and so I'm just going to do log 23 for this first one, and 1.3617, etc., etc. remember that I can always check it with exponential form to make sure I did it right. If I did the swirl method, that would say 10 to the, and then I'm just going to put second answer because I want that whole decimal in there. And notice when I put that answer in there and I take 10 to that power, I do get 23. So I feel good about my answer. Notice on my slide, I rounded it to 1.3617. And again, that's just a cautionary tale about don't round. So if you have the fancy calculator like I do, use that second and then answer, which is above the negative sign there at the bottom. That just takes your answer from the previous question and puts it into your function. Now notice that second one looks a little crazy because we haven't talked about this, and I actually have a video in a little bit, or maybe next week, I can't remember when it is, that talks about the change of base formula. But that's essentially what this is. I want to find log base 2 of 34, and if you'll notice, my log button doesn't allow me to change the base of my log. My calculator does log base 10, and I think there is a function in there somewhere, but we're just going to go with the change of base formula because everybody can use it. So what the change of base formula says is if you need to change the base, and in this case I'm going to change the base to base 10, all I have to do is set up a fraction with the log of whatever I'm finding the log of, in this case 34, and divide it by the log of whatever the original base was. So the original base was 2, and so I'm just going to plug it in just like that. So again, notice I didn't find log of 34 and then round it, and log of 2 and round it, and then divide two rounded answers. I'm just doing everything in my calculator. So that is the change of base formula, and again, there's a video, I think it's early next week, that talks about this in more detail, but it's really not rocket science. Just make sure that the number that you're taking the log of always goes on top, and the base always goes on the bottom. Last one, natural log of 0.45. Again, I'm just using the natural log button instead. 0.45, so I'm just plugging it in to find my solution. Again, I strongly encourage you in this case to not just rely on your calculator. I have shown you the change of base formula, so a lot of people go to this and say, okay, well I'm just going to use my calculator to take log of 64 divided by log of 4. And yes, you're right, that is going to give you the right answer. But again, next week we're going to be solving exponential and logarithmic equations, and you'll need to know all of these handy little tricks that we learned this week. So don't cheat. Put in the hard work this week so next week's easier. Rewrite this as 4 to what power equals 64. And then you can reason this through. 4 times 4 is 16. 16 times 4 is 64. That was 3 times that I had to multiply by 4. Natural log of 22. Again, I could try to write it. E to the x equals 22. But that's really hard to try to figure out in my head, and so I'm not even going to try because, I mean, I'm smart, but I'm not that smart, right? So I'm just going to take the natural log of 22 in my calculator, and I get x, is approximately equal to 3.091. Next one, there's this handy little trick, and I haven't taught you the trick yet. It's, I think, the first video next week. The first video next week talks about the power rule, but let's go ahead and preview it now. Let's use our calculator, since we don't know the rule, and just go ahead and take the natural log of e to the 5th. And when I do that, I get an answer of 5. Well, that was really easy. Well, what does the power rule say? The power rule says if you have a power, I can pop it out to the front, so I can actually rewrite this as 5 times the natural log of e. And the natural log of e, we've already done a couple of practice. The natural log of e is 1, so this is 5 times 1, because this, remember, is e, base of e to the e, so it's just 1. So 5 times 1 is 5. So power rule, again, says you can move that exponent out to the front. We'll use that one a lot. So again, we haven't officially learned it, but it's a good preview. Next one, or last one, I guess. Again, 8 to the x equals 1/2. So again, what I'm looking for here is 8 to what power is 1/2? And these are the trickiest ones. Whenever I have to take a root, because obviously I'm going from 8 to 2, which is a smaller number, which means I have to take a root. Whenever I'm taking a root, that means my exponent is going to be a fraction. So x should be a fraction. So let's look at that part first. 8, what root of 8, so what number would go here? What root of 8 would be 2? Not 1/2, but 2. Well, if I took the cubed root of 8, because 2 times 2 times 2 is 8, the cubed root of 8 would be 2. So right now, x would be 1/3. Because I'm using the cubed root, I turn that into a fraction because it's a root. Now, if I took 8 to the 1/3, I would get an answer of 2, right? That's what I came up with here. But what I want is an answer of 1/2. And so whenever I have to do the reciprocal, which means 2, I want to flip it over and make it 1/2, then I'm going to use a negative exponent. So my answer is going to be negative 1/3. Here are some great properties of logarithms, and you might have figured them out as we went through already, but if you haven't, remember, if I have log base b of 1, I'm going to get 0 because b to the 0 equals 1. If I have log base b of b, we kind of just talked about this one, and it's the same for the natural log. Natural log is a base of e, that's just 1. Again, since e to the 1 is e, or b to the 1 is b. Log base b of b to the x, this is that power rule we just talked about. Remember, x moves out front. Same thing here. 2x would move out front. This would be 2x times the natural log of e. We just talked about the natural log of e is 1, so that's where I get 2x from. Same thing goes, and this one's a little bit trickier. Just like this was same base, base b, this is same base, base b. Those things cancel out too, and I just get the x. This is base e, those things cancel out, I just get the x squared. So these are some great properties we're going to use over and over. This video is getting a little bit long, so I'm going to try to go a little bit faster through these examples. But again, log base 14 of 14 means 14 to what power is 14? And it's 14 to the first. 14 to what power is 14? So I got 1. Log base 10 of 10, same exact idea. 10 to the first is 10. We already talked about this one is just 1 because log base e of e is 1. So all of those are 1. Anything to the 0 power is 1. So whenever I've got a log of 1 here, I know that was the 0 power. This is 144 to what power is equal to 1? And obviously it's to the 0 power. This one, log base 8 of 8, base and base, those cancel out, means x is the only thing left over. Natural log always has a base e, so base e and base e cancels out. 4x is all that's left over. Base 5 cancel out. I just get 22. So it's like 22 times 1. Base 10 and common log, which is base 10, cancel out. I just get 3x. And then base x and base x cancel out, and I just get 2. So hopefully those are pretty straightforward after all of the properties we talked about. Here's a few for you to try. Again, I'm not going to spend a ton of time on them because I don't want this to be a 30-minute video, so press pause, try the questions, press play to see how you did. Log base 4 of 4, remember if you have to write it out, 4 to what power is 4? Well, x must be 1, 4 to the first power. Remember, if the bases are the same, essentially those are canceling, and I'm just left with the exponent, which would be 1. Same thing here, this is log base 10 of 10. Those guys cancel, it's just e. Whatever the exponent is left over. Log base pi of 1, goodness, I mean, how do I even know? Because I can't really cancel that. So this one, I'm going to have to use change of base formula to do log of 1 divided by log of pi in my calculator. So remember, change of base says we can use a new base, in this case base 10, and I'm going to do log of 1 divided by log of pi. And in my calculator, I get 0. And again, that's because log of 1 is 0. Natural log is a base e, so natural log base e means my answer is 4x. E to the natural log, remember base and base cancel, I just get 4. And then base A, those cancel, I just get 198.